Hi, I'm Paresh,
Hi, this is Manjiri.
and we've built a streaming platform with stateful algorithms and interactive active UI to process stock activity and news.
I'll start with the motivation behind this project. Portfolio management tools are basically hand-rolled by individual teams for their calculations and platforms. We had previously built a single calculation scalable platform that gave fund managers a ticking view of their holdings. So we had implemented a basic version of this in the lower level course E6893 in fall 2015. So in this project, we have reiterated on the same idea and enhanced it using the tools and technologies used in this course. The calculators perform meaningful operations on real data as we learned in this course. We have used alchemy scoring of Twitter streaming data, then we actual prices from Google and Yahoo Finance, and then price predictions were run on GPU grid using PyOpenCL. All operations were performed live and results are presented in real time. We have also used some visualization techniques using high charts from AngularJS to address information overload and provide meaningful reporting rather than dumping data to a user.
So let's actually take a look at the platform. What's this that we're talking about? So as you can see, this is a Kafka event bus running um, on the platform. Um, and it actually has some of the topics that are already defined. And what we're seeing here is the platform actually pumping the data through. So it's pumping both trade information, prices are coming through Yahoo Finance through a Polar, as you can see highlighted there. And and then the Vertex WebSocket handler is actually pushing the prices through, but it's actually pushing the calculated information along with the trade information to give you holdings. And as you can see, the delta calculations, the delta predictions are also provided here. So the delta predictions are calculated using windowed prices that are fetched from Google Finance, and all of these are again pumped out through the through Spark streaming, which joins all these different streams by keys. Um, and then here you can see that the data is ticking live. This was actually real live market data, and this stream was captured. The screen was captured while the market was open. As you can see, this is the dashboard that a portfolio manager would see. Obviously, the first thing that was of interest was the data grid itself, but there's much more information here, because just seeing all the information flattened out is not as useful um, as as actually seeing them um, partitioned by by asset. So all of these, this entire UI, and all of these are built using industry standard frameworks and tools. So, for example, the look and feel is using the Bootstrap UI toolkit, and these charts actually are bound to the scope, um, to, with data being pumped out through WebSocket. So these charts actually get recalculated in real time using high charts, because high charts actually has this integration with um, has this integration with Angular. Now, Bootstrap also gives us this nice look and feel, and actually lets us drill down into all the different visualizations that are available. So we also have another sample visualization, again, that is bound to the scope, where you can see the data for each account and what the holdings for some of the interesting assets are. So here you can see that there are 3 accounts that hold Microsoft, um, and only 2 that hold Berkshire Hathaway, because those are the 2 that we were looking at. And there are some other links here that show us some of the technologies that we have used. So that was a look at the platform live running and pumping data real time along with the calculated values. Um, So some of the tools and technologies that we've used here, the sentiment column that was displayed there is still coming from Twitter streaming. Um, but what we've learned in this course was the Alchemy API package, which is really simplifies the sentiment score. It actually gives us for each corpus for each document what the sentiment score was. Now, generally, the sentiment comes out as positive, but what we've done here is we're calculating the sentiment for the stock and its sector and the overall market. So we'll talk a little bit more about how we weighted the sentiment. Some of the other information that sources that we've used are Yahoo Finance for uh, live prices on demand, and Google Finance for windowed prices because it gives us within intervals of a minute, as far back as we want to go. We used a 30-minute interval like we did in class. Um, all this information is fed onto Spark Streaming. Now, Spark Streaming actually has good adapters for Kafka Event Bus and also for Twitter streaming. The price predictions were actually calculated using PyOpenCL on the GPU grid, which is how we had done it in class. And the calculators were implemented in Scala for Spark Streaming and in Python for PyOpenCL, PyCUDA, and the actual platform and some of the utilities were built using Java. For example, Vertex Event Bus is started using Java, but it also gives us WebSocket handling support. Now, the HTML5 WebSocket support in the browser was used to be able to allow us to send push notifications, and the interactive grids that you saw were D3JS, like the professor had explained. The visualization um, uh, technologies now are not using Flash anymore; they're using SVG. And HighCharts actually is a JavaScript framework that plays very well with Angular, and it just binds to whatever data is in scope to repaint itself. So that's what we've used here. So a little bit of an overview here. We've built a live dashboard. It provides the net asset value, which is what the value is for every holding within an account, and also the sentiment score that's calculated with some weighting algorithm that we'll go into, and the price trend that we kind of think looking at the most recent activity. So the Alchemy API usage we talked about earlier. The data that is used is actually Twitter streaming. Um, the standard statistics functions are used for doing our price predictions, things like standard deviation, min max, and the implementation is using the power of the GPU. So we've used in our case we had OpenCL support, but with our previous assignment we also had a CUDA support in one of our platforms which had NVIDIA graphics card. So we have the ability to plug in both calculators. Um, Trades and prices are both fed into the bus, Kafka bus, and Twitter streaming joins the information, um, reduces by window for net asset value, and by key for the weighted sentiment calculation. Um, we talked a little bit already about the Vertex WebSocket support. That's what's used to send the information and really what the delta information is out to the UI. Um, the price trends, the graphics are displayed using Angular high charts, and the live ticking prices are grid is built using Angular UI grid. The power of this grid is actually that you just provide it the data itself bound to the scope, and it's able to paint just using the metadata what the grid should look like. So a little bit about how these tools fit in together, going from right to left. The funny icon that you see in the top right is actually the Firehose API provided by Twitter streaming, which is fed into Spark streaming using Spark's built-in adapter, which then uses Alchemy API to calculate sentiments. Again, we'll go into what the three different sentiments are and how we weight them, but we for every stock we're assigning Twitter stream filter, and for the stock sector and the market at large. We've got three filters going, and so we're calculating the sentiment for each of those three for each stock, and Spark Streaming is then pumping the sentiment score onto Kafka. Google Finance and Yahoo Finance prices are pumped onto Kafka. Google Finance actually goes through PyOpenCL to get predictions which are pumped onto Kafka, and trade feeds are just mocked out using what we've seen in the industry, some typical trades, and then Spark Streaming joins all of this information and then reduces them by a window, and it calculates the latest data set, and it pushes it onto the output event bus output topic on Kafka. So Vertex actually has a subscriber started which gets these micro events, and then it keeps track of every WebSocket peer connection that it is maintaining, and it pushes the notifications for these micro events out to the interested subscribers. And going to the top left now, which is where we've reached, the grid and the charts are using the data that is bound to the scope to automatically refresh its ticking information and repaint its UI, its charts. Um, so talking a little bit about the visualization that we've enhanced here. We've used AngularJS as our platform, and AngularJS is completely built in written in JavaScript itself natively, and it's completely client side. It's very extensible. People can plug in their own directives to HTML, for example, and it's very well structured for plugging in your own logic, providing dependency injection like underscore JS libraries that we provided, bootstraps libraries that we provided, high charts, and so on, and also to let us write tests. And we've got HTML5 and WebSockets to push the notifications out. The UI grid, like and the high charts as we described just earlier, this is what they look like, and they're bound to the scope data, and they because of the way Angular binds its data, we get real-time updates on the UI.
Uh, Getting into details on Alchemy API. So yeah, we have used an Alchemy API for sentiment scoring. So it provides an easy to use mechanism to identify positive negative sentiments. We have run the following code in Spark, which is basically PySpark and Java API implementations, which used Alchemy API to calculate sentiment scores for each stock. Then coming on to Google Finance and Yahoo Prices. Yahoo Finance provides latest price ticks, which are Polar, which was implemented in Python, publishes onto platforms bus using the Kafka Python client. And Google Finance provides a window of prices in 1 minute intervals, and these were used by our predictions calculator. Then, as we previously stated, that we have used GPU programming, OpenCL, we used OpenCL and PyOpenCL. So we use these to implement some of our algorithms like standard deviation and min, max, and average for our price predictions.
As you can see here, the platform that we use, it comes with some native OpenCL support, but obviously using Python lets us reuse our algorithms because we have other platforms. We had an NVIDIA graphics card which supports CUDA. We took the opportunity here to make sure that also runs on an OpenCL platform, and it ran without a problem, which is why PyCUDA and PyOpenCL come very handy.
Then we used Twitter streaming. So we used Twitter's REST API calls. So Spark streaming already comes with an adapter of Twitter's API, which is used to define filters for each stock. And the streams have their sentiment calculated, and the resulting RDDs are joined by products. And then the final score is calculated by weighting outlier behavior higher or using an average score in normal cases.
And as you can see, we are using Alchemy API to calculate the sentiment score, which makes it extremely simple because it's much faster. The API is really fast, and the scoring algorithm just gives a little bit extra weight if the stock that we have a filter on is an outlier, or otherwise it just takes the average score.
And we use Spark streaming. So basically, as we know, Spark is the leading choice when selecting any big data technology to handle the first and second V's in analytics, which is high volumes and high velocity. And Spark has solved the problem of parallelizing operations on large data sets, that is in HDFS, and scheduling jobs across the executors using its own driver or yarn, etc. So in this project, we use Twitter streaming to stream new articles and perform sentiment analysis using Alchemy API. Kafka is used for transactional and market data. Scalability comes from being able to add executors or stream consumers as needed.
Kafka actually plays very well with Spark Streaming. That was one of the first adapters that Spark Streaming provided. So the integration comes built into the APIs, and the ability to replay the messages provides resiliency for micro batches because it doesn't have to load the entire data into memory when it's doing its calculations. And so the operations that it provides work very well when the expectation and the requirement is delta calculations. Kafka is a fault-tolerant distributed messaging system and can be scaled by just adding extra brokers. So diverse producers can provide trades, research scenarios, price predictions, sentiment scores, which is what we've done, and different consumers can pick them up and do their processing as needed. And as more metrics were needed, more brokers could have been bought online. The thing that tied it all together was Vertex. Vertex is a RESTful API provider and an event bus implementation, and it's polyglot, so we were able to run Python, Scala, Java all within it, and host our Angular web application on here. So this is some information about our contribution. It was totally a team effort, and we managed to make it just in time. So we wanted to take a minute to
We wanted to thank Professor C.Y. Lin and all the TAs, Eric, David, and Sanjana. And
it definitely was useful to take this course again, the advanced level course again. We definitely learned some really native low level GPU programming and some more uh, interesting difficult challenges about visualization when it comes to big data and so on. So this was definitely very very enriching experience.
yeah.